All right, so in this video, we're going to take a look at example 11 in topic 9.1. We notice that we have cosine, so we start with the one we can get for free, which we know the reciprocal of cosine is secant of theta, which would be 8 over 3. And then I'm going to go ahead and draw my triangle to get the other 4. So I'm drawing my triangle. And I know that cosine is the adjacent over the hypotenuse. And I know in my triangle here, this is opposite, this is adjacent, this is hypotenuse. So across my adjacent leg is 3, my hypotenuse is 8. I'm going to find this other leg by using the Pythagorean theorem. So we've got 3 squared plus question mark squared is my other leg equals 8 squared. That looks terrible, sorry. Okay. 3 squared is 9. 8 squared is 64. I need to do 64 minus 9 because I'm going to get the 9 to the other side. So that is equal to 55. I'm going to take the square root of both sides, which is the principal square root, so it stays positive. So my other leg is the square root of 55, which I do not believe breaks down at all. So we're just going to leave it that way. So now I'm going to find the sine. So sine is opposite, which is square root of 55, over hypotenuse, which is 8. Then the cosecant of theta would be the reciprocal of that, 8 over the square root of 55. I need to rationalize that. So that gives me 8 square root of 55 over 55. So because I multiply top and bottom by the square root of 55, multiply across the top, I get 8 square root of 55, and then the radical square root of 55 times itself is just the number underneath. Then I need to find the tangent of theta. The tangent is the opposite, square root of 55, over the adjacent 3. And then I need to do its reciprocal, which is cotangent, so which will give me 3 over the square root of 55. I am going to rationalize by multiplying top and bottom by the square root of 55. Across the top, I get 3 square root of 55, and across the bottom, I get 55, because a radical times itself is just the number underneath. We're going to go ahead and skip 12 and 10.